Okay, see Lindelof videos, AP Calculus, indefinite integration. I'm going to use U substitution to solve this problem. We're asked to evaluate the indefinite integral of 2x plus 1 over the square root of x plus 4 dx. This is horrible to look at. I looked at it, I was like, can I do any algebra here and simplify this, break this into pieces that I know? I don't know the integral of this thing, so I'm kind of stuck. So this is what I'm going to do. I'm going to use this U substitution. I'm going to say, let U equal this x plus 4 down here. So x plus 4. And then I'm going to take the derivative of that and say that du dx is equal to 1, right? If I take the derivative of x plus 4, it's just 1, isn't it? A little bit of extra work, a little bit of extra algebra. I get du is equal to dx. So let's see what we got so far. First off, now we have 2x plus 1 over the square root of u du. So this is looking a little bit better because I can actually partition this thing out, but I still have x and I still have u. So I wonder, is there something I can do to get this term x in the term of u? So I'm going to go back to what I had, which is that u is equal to x plus 4. And if you do a little bit of algebra, you get that u minus 4 is equal to x. So hopefully you can see that now. I have a replacement value for x. It says here that x is u minus 4. So I'm going to go ahead and use that substitution value. And it's 2 times x, but x is u minus 4. So here's my u minus 4. Remember, there was a plus 1 at the end of it, so there's my plus 1 all over square root u du. I guess this very second, it might not look like we're getting anything done, but we are actually getting a ton of work done here. I'm going to go ahead and do some algebra. I'm going to distribute to here and here. I'm going to get the indefinite integral of 2u minus 8 plus 1 all over square root u du. If you don't mind, I'm going to, instead of writing another line, I'm going to go ahead and clean this up. Negative 8 plus 1 is negative 7, isn't it? It's just a little bit of arithmetic. Also, if you don't mind, I'm going to say that I'm going to do this. I'll show you what I'm going to do here, but I'm going to rewrite this again. I'm going to say that I have the indefinite integral of 2u times u to the negative 1/2. We know that square root of u can be rewritten as u to the 1/2. Because it's in the denominator, we know that the exponent had to be negative, so that's where the negative sign came from. So that's all I'm doing there, just taking a little piece of algebra that I happen to know. Minus 7 times u to the negative 1/2, right? All I'm doing is partitioning out this fraction. If I had 1 plus 2 over, if I had 3 over 5, I could rewrite it as 1 over 5 plus 2 over 5. I could. And in this case, that's what I did. I just broke this piece out. So that's going to work for me. From here, all I want to do, frankly, all I want to do here is go ahead and start to integrate. So as I do, actually I have to clean this up a little bit, don't I? So this is 2u to the first, to 2 halves. So we get indefinite integral of 2u to the 1/2, don't we? Because when we combine exponents, we add them when we're multiplying. Minus 7u to the negative 1/2. Whole thing du. Your professor's definitely going to want to see that. So, excuse me, from here I'm going to go ahead and integrate. So I'm going to take 2 times u to the 3/2 over 3/2, right? Minus 7 times u to the 1/2, right? I'm incrementing this over 1/2 plus c. You could get lucky on the multiple choice part of the exam. I doubt it, but you could get lucky, and they could provide you that as the answer, but they're not going to. So I'm going to go ahead and clean this up again. See that this is a complex fraction down here, so this comes up this way. This gives me 4/3 u to the 3/2 minus, this comes up, minus 14 u to the 1/2. So what are we going to do now? Well, plus c. You would hope we could be done here, but on the multiple choice section, they're not going to let us be done. They're going to definitely make us dig this out more. So we can't even resubstitute yet. What we're going to do is this. I want these fractions to be of the same denominator. This is 14 over 1, isn't it? But if I multiply this whole thing by 3 over 3, I would get 42 over 3. And if you check 42 over 3, you'll see that that actually is that 14. Now I'm going to have to factor all this crap out. So I can factor out, I can't factor out 4/3, but I can factor out 2/3. So I get 2/3 times, oh look, I can factor out this too. The lowest value, exponential value I have is 1/2, so I can factor out 2/3 u to the 1/2 times, so to get back to 4/3, I'd have to multiply by 2, u to the, I'm going to write it for a second, but to the 2/2, because 1/2, u to the 1/2 times u to the 2/2, you'd add these, wouldn't you? So that's where I got that. And I'm going to factor out a 2, I'm going to factor 2 out here, so 2 times 21, 2/3 times 21 would be 42/3, right? I don't have the u to the 1/2 because when I multiply it, it gets back here. Plus c. So now you're like, okay, good, we're finally done. No, we're not actually done yet. We have to rewrite this again. We have 2/3 square root. Remember, we had u was worth x plus 4, so we have to resubstitute, right? Times 2x plus 4 is the value of u, right? Minus 21 plus c. And believe it or not, you have to continue and do all this algebra. So I'm not going to do the whole thing. I'm actually going to, I think I'm going to stop here. But we have to kind of keep going. And here you get 8. And this, I think it actually turns out to be 2/3 square root x plus 4 times the quantity 2x 8, 13 minus, minus 13 plus c. So in a way, you're really looking forward to doing the multiple choice part of the AP exam because you figure it would be easier. And the way they're going to get us is they're going to check our intermediate algebra. So hopefully this was helpful. If you have any questions or comments, let me know. And if you haven't already subscribed, please do. Thanks.